Imagine this. You wake up in the morning, pick up your phone, and ask a simple question. What's the weather like today? Within a fraction of a second, a pleasant voice responds with the forecast for your exact location, perhaps even with a friendly tone. But have you ever stopped to wonder what just happened behind the scenes? How is it that a machine understands your words, interprets your question, and answers with relevant, human-sounding information? The answer is artificial intelligence. But what does that even mean? And how does it actually work? Artificial intelligence, often abbreviated as AI, isn't magic. It isn't a thinking being, and it definitely isn't a sentient robot with emotions and dreams. AI is, at its core, just mathematics, statistics, and a lot of data. That's it. And yet, that combination of cold logic and massive datasets has become powerful enough to change how we live, communicate, work, and think. Most of what we now call artificial intelligence is based on a concept called machine learning. That's a method of programming where, instead of giving the computer a strict set of rules, we let it learn patterns from data. In other words, we don't tell the machine what a cat looks like. We show it thousands of pictures of cats and thousands of pictures that don't contain cats, and it figures out the difference on its own. In traditional programming, if you wanted a system to detect cats, you'd have to define specific features, like pointy ears, whiskers, a tail, and 4 legs. But that method breaks down quickly, especially when the cat is in shadow, curled up, or looks slightly different than expected. Machine learning takes a completely different approach. Instead of telling the machine how a cat looks, you let it analyze examples and build its own internal logic for what makes a cat a cat. The most advanced AI systems today are built on what's called artificial neural networks, systems inspired by the structure of the human brain, though they are not direct copies of it. A neural network is a web of interconnected nodes, or neurons, each performing a simple mathematical operation. These nodes are arranged in layers: an input layer, multiple hidden layers, and an output layer. As data flows through the network, each neuron calculates its output based on the inputs it receives and passes that result forward. The key to learning lies in something called weights, numbers that determine how strongly one input affects the next step. Training a neural network means adjusting these weights over and over again until the network gives the right answer for a wide variety of inputs. This training process requires vast amounts of data. For example, one of the most famous image classification datasets, ImageNet, contains over 14 million labeled images. Training a deep neural network on a dataset that large can take days or even weeks and requires powerful hardware, often involving dozens or even hundreds of GPUs running in parallel. The result of that training is a model that can recognize faces, translate languages, detect fraud, or generate human-like text. But let's be clear, that model does not understand anything in the human sense. It doesn't know what a cat is. It doesn't know what a sentence means. It only knows patterns, statistical correlations between inputs and outputs, between words and images, between sounds and responses. It is incredibly good at mimicking intelligence, but it does not think. It predicts. A major breakthrough in artificial intelligence came in the year 2017, when researchers at Google introduced the transformer architecture. Unlike previous models that processed data in sequence, transformers could analyze entire sequences at once, capturing long-range dependencies and relationships between elements. This innovation led to the creation of language models like BERT, GPT, and T5, and transformed how we build and use AI in practice. Take GPT, for example, the model family used by ChatGPT. GPT-3, one of the most well-known models, was trained on over 500 billion words gathered from books, websites, conversations, and more. That is over 200 times the size of the entire English Wikipedia. To train it, researchers used a supercomputer with thousands of graphics processors, and the cost was estimated in the tens of millions of dollars. Yet even GPT-3 does not understand what it writes. It simply predicts what the next word should be, based on everything it has seen before. This kind of AI is known as narrow AI. It's designed to perform a specific task extremely well, whether that's recognizing speech, classifying images, or recommending content. But there's also the idea of general AI, a hypothetical system that could solve any intellectual task that a human can do. We're nowhere near that level yet. Most experts believe that true general AI, if it's even possible, is still decades away. Some say 20 years, others say 50, and many believe it may never happen. In the meantime, artificial intelligence is being used in hundreds of real-world applications. In healthcare, AI helps doctors detect cancer earlier than ever before. In logistics, it optimizes delivery routes in real time. In agriculture, it helps predict crop yields and detect diseases. In finance, it powers fraud detection systems. And in entertainment, it's shaping the music we hear, the videos we watch, and even the art we see on our screens. But AI also brings serious challenges: ethical dilemmas, data privacy concerns, bias in decision-making, and the risk of misinformation. All of these are real and growing problems. Because AI learns from our data, it can also absorb our biases, repeat our mistakes, and amplify our worst assumptions. For example, studies have shown that facial recognition systems can be significantly less accurate for people of color, simply because they were trained on non-diverse datasets. That's not a bug, that's a mirror reflecting what we gave it. There's also the question of jobs. According to a report published in 2023, up to 44% of tasks in administrative and customer service roles could be automated within 5 years using existing AI tools. That doesn't necessarily mean all those jobs will disappear, but it does mean many of them will change. And as with every major technological shift in history, from the printing press to the internet, society will have to adapt. So no, artificial intelligence is not a magical brain. It is not alive. It is not conscious. But it is powerful, perhaps more powerful than any tool we've ever created. And like every powerful tool, how we use it will define what kind of future we build. Next time you ask your phone a question, generate an image from a prompt, or get a recommendation for what movie to watch. Remember that behind the curtain is a machine, built on millions of examples, trained for days or weeks, optimized with math, and utterly unaware of what it's doing, but doing it brilliantly. That's artificial intelligence, not consciousness, not magic, just technology, breathtaking, imperfect, and entirely real. Subscribe us for more videos.